So I thought I'd record this feedback for you for this problem from the practice exam, because there's a question just like this on uh, on exam 2 here. So when you see a or probability, you want to think about this as the addition rule, and this is on page um page 55 in the textbook. Okay, so we want to go check that out. And then because it's an or probability, I'm going to take the probability of G plus the probability of H minus the probability of them both happening. So in this case, it's going to be 0.5 plus 0.3 minus 0.15. And I think that's 0.65 if I'm doing my arithmetic right. Part B is a conditional probability. What that is, that means we're going to find the probability of both H and G happening over the probability of G happening. So it's saying what's probably H is going to happen given that G's already happened. So there's our probability of G and H. We don't have to do any kind of multiplication rule. And then we're going to divide that by the probability of G happening, which is 0.5. So you said 0.4. Let's see if I get the same answer. I think it's what is it? I'm sorry, I'm going to do this. I don't have a calculator right in front of me, so I'm going to do this. Let's see. So that's 15 out of 50. So that's 15 out of 50, right? And if I want to make it out of 100, I got to double both. So that's 30. So 0.3 is the answer for B. Now you're reversing it for the other way. For C, we're going to say that the denominator is going to be with the probability of H happening. So it's going to be 0.15 over 0.3. 15 over 30 is 0.5. Okay. And find the probability. So that's this C. Then G and not H. Well, let's see. And means that's a multiplication probability. So let me do some erasing here. So we're looking for G and not H. Well, not H is going to be what? 1 minus 0.3. That's 0.7. My gut feeling is this. I'm on a complete blank this morning for this, but I think because it's an and probability, I'm going to multiply them. I'm going to try it a different way just to double check my answer. And probabilities usually mean we multiply them. I mean, this is the and for both G and H, but we don't know the probability. Well, we know the probability of G and H, but we know the probability of both of them. So I'm thinking this is what we're going to do. I'm going to try probability of G is 0.5. And the probability of not H is 0.7. So I'm going to multiply those and get 0.35. That's what I'm thinking. I'm going to stop this, set some stuff up, and come back and check my work. So I said initially that it was going to be 0.7 times 0.3, 0.5. So I said by doing that multiplication property, it was going to be 0.35. So let's see how I'm doing. So what I did is I treated, instead of a probability, I said, well, what if there's 100 items or whatever it is? That way you don't have to deal with decimal points. And I filled in what I know. They told me the probability of G is 0.5. So if I've got 100 items, 50 of them are G. And if I've got 100 items, 30 of them will be H. They all know that 15 are both G and H. So now let's fill in. I think I know enough to fill in the rest. So 30 plus 70. Here, let me go to a different ink so that I can see what I calculated. So 70, because 30 plus 70 is 100. And then 15 plus 15 would be 30. And 35 would be 50. And if 70 of them are not H, that would have to be 35. And then this together would also be 50, and that checks. So what's the probability of G and not H? Isn't that this one right here? G, let's see, G, but not H is 35, and then that's what I calculated. So I okay do it that way. It's always good to have a couple of ways to do things to check yourself out. This is like that ski problem or the RH factor and type O blood problem in the textbook. So that's how I set that up. And then because these two events here, let me clean this up because this is a biggie. Here, let me here, gonna delete all my drawings. Here we go. See how it says that G and H can occur? Well, events are mutually exclusive when they both can occur at the same time. So since this probability is not zero, these things are not mutually exclusive because they can both happen at the same time. Okay, so keep that in mind. A question just like this on, at least on exam two, part two, there's a question just like that. So if they can both happen at the same time, they're not mutually exclusive. Hopefully this helps you.